Hi everyone, good evening. Can you all hear me? Am I audible to all of you? Please write yes in the chat box if you can hear me. Okay, great. Fine, so welcome to this session by iQuanta, okay, the event CAT before CAT, a very famous initiative that we do every year. I'm just waiting for a couple of more students to join and then we'll get started, okay. Today's session is based upon remainders and divisibility, okay. Hi Gaurav, hi Aniket. Good evening everyone. So let's get started. Basically you might be knowing the agenda by now. We are doing these daily sessions in the event CAT before CAT, and it is actually CAT before CAT because this entire initiative is an intensive drill, I would say. ये एक drill है rather than just random classes. It's a very good drill जिसमें हम सारे concepts cover कर रहे हैं, okay? And this is a 50-day initiative. You might be knowing about it by now. Week 1, 2, 3, 4, 5, 6, 7, तो 7 वीक्स का इवेंट है जिसमें कुछ सेशन जो वीक 1 में हम लेने वाले हैं वो अलाइंड हैं आपके. आई थिंक यू मस्ट हैव ऑलरेडी गॉन थ्रू अभिषेक सर का फैक्टर्स वाला लेक्चर, राइट. टुडे आई एम हियर टू डील विद डिविजिबिलिटी एंड रिमाइंडर, एंड एज यू नो कैट 2024 में भी आई थिंक रिमाइंडर्स के कुछ क्वेश्चन आए हैं, राइट. सो रिमाइंडर्स इज़ ईजी टू लर्न एंड वेरी स्कोरिंग, इसलिए आप सबको आना चाहिए. आई वुड सजेस्ट कि जो लोग देख रहे हैं, रेगुलरली आ रहे हैं, दे शुड कम एवरी डे, बिकॉज इस ड्रिल को अगर आप कर लेते हो एज एन एस्पिरेंट, अगर आप यहाँ से बाहर निकलते हो आफ्टर 50 डेज़, काफ़ी इम्प्रूवमेंट आप में आ गया होगा. काफ़ी कुछ ऐसी चीज़ें होंगी जो शायद आप भूल चुके होगे या भूल रहे होगे, वो थोड़ी सी रिफ्रेश हो जाएंगी, ओके. बिकॉज अ लॉट ऑफ स्टूडेंट्स आर गोइंग टू पार्टिसिपेट इन दिस. इनफैक्ट कल हमारा आई गेस मॉक भी है ना, iCAT 7 जो ऑल इंडिया ओपन मॉक है. अ लॉट ऑफ स्टूडेंट्स विल बी राइटिंग इट. आई थिंक iCAT 1 को लगभग 15-20 हज़ार बच्चों ने दिया था. वी आर एक्सपेक्टिंग मोर देन दैट, ओके. 20 हज़ार से ऊपर बच्चे शायद iCAT जो 7 है आपका उसको लिखेंगे. कल ऑल इंडिया मॉक है. सो यू विल बी नोइंग कि भाई मेरी क्या पोजीशन है अभी इंडिया में, राइट. कैसा आप परफॉर्म कर रहे हो, एंड दैट कुड बी अ वेकअप कॉल फॉर मेनी ऑफ यू. सो डू कम टू दिस सेशन एवरी डे. आज हम फटाफट क्वेश्चंस करेंगे. 10-12 क्वेश्चंस हैं रिमाइंडर्स के, जिसमें आपके सारे जो रिमाइंडर्स के थ्योरम्स हैं वो टचअप हो जाएंगे, एंड इट्स अ गुड रिविजन फॉर यू ऑब्वियसली, ओके. सो फैक्टर्स की आप लाइव क्लास कर रहे हो, फिर प्रैक्टिस कर रहे हो, फिर डिविजिबिलिटी कर रहे हो, प्रैक्टिस कर रहे हो, iCAT 7 कर रहे हो, है ना. देन उसके बाद आपका HCF LCM फैक्टोरियल्स एंड मिसलेनियस कंसेप्ट्स, फिर आपकी मैराथन भी है इसमें. तो आपकी डेली क्विज तो आ ही रही है, ये सेशंस हो ही रहे हैं, राइट. और आपकी फुल लेंथ मॉक्स भी 2 हैं इस पूरे इनिशिएटिव के अंदर जो ऑल इंडिया मॉक्स हैं. तो डू फॉलो दिस इवेंट, ओके. इस तरीके की हैंड होल्डिंग प्रोबेबली बहुत सारे प्लेटफॉर्म्स नहीं करते हैं. ये अब वो टाइप का इनिशिएटिव आ चुका है कि जहाँ से आपकी बिल्कुल हैंड होल्डिंग करी जा रही है. इसको अगर आप कर लेते हो यार तो बहुत फ़र्क पड़ जाएगा. जो यहाँ से भी नहीं कर पाएगा तो फिर इशू है, इज़न्ट इट. फिर एटीट्यूड में इशू है. फाइन, लेट्स गेट स्टार्टेड विद दिस. वी हैव फर्स्ट क्वेश्चन ऑन योर स्क्रीन, एंड रिमाइंडर्स काफ़ी लोगों का फेवरेट भी होगा बिकॉज जल्दी होते हैं रिमाइंडर्स के क्वेश्चंस, राइट. बस रिमाइंडर में आपको एक चीज़ का ध्यान रखना होता है, कैलकुलेशन. यहाँ कैलकुलेशन मिस्टेक्स बहुत करते हैं स्टूडेंट्स, ओके. यू डोंट हैव टू डू एनी सच कैलकुलेशन मिस्टेक. इफ़ यू डील विद कैलकुलेशंस एंड ऑल, आप रिमाइंडर के क्वेश्चन को 100% कर पाओगे. एंड रिमाइंडर्स के क्वेश्चन कैसे भी आ जाएं, दे आर ऑलवेज सॉल्वेबल. यू विल ऑलवेज हैव अ वे टू सॉल्व रिमाइंडर्स क्वेश्चंस, ओके. यू कैन सी फर्स्ट क्वेश्चन ऑन योर स्क्रीन. डू गिव इट अ ट्राई. देखो इसका आंसर क्या आ रहा है, एंड देन आई विल एक्सप्लेन, ओके. रिमाइंडर्स के कुछ क्वेश्चंस जो होते हैं वो थ्योरम्स पे बेस्ड होते हैं, कुछ थ्योरम्स पे बेस्ड नहीं होते हैं, ओके. जैसे कि ये क्वेश्चन आपके सामने है, फाइंड द रिमाइंडर व्हेन दिस की पावर दिस समथिंग पावर्स, पूरी बड़ी बड़ी पावर्स हैं, इज बीइंग डिवाइडेड बाय 4, ओके. सो रिमाइंडर, सबसे पहले रिमाइंडर्स में आई होप आप लोगों को रिमाइंडर्स आता होगा बेसिक थोड़ा बहुत. सबसे पहले देखो, रिमाइंडर्स तो हम बचपन में भी करते हैं. यहाँ फिर क्या अलग है, जो चीज़ यहाँ अलग है दैट इज़ फर्स्ट आपका नेगेटिव रिमाइंडर. मैं बस एक टचअप दे दे रहा हूँ आपको, ठीक है. नेगेटिव रिमाइंडर. नेगेटिव रिमाइंडर सबको पता है क्या होता है. ये वैसे तो एग्जिस्ट नहीं करता, बट इट हेल्प्स अस टू सॉल्व द क्वेश्चंस. कैलकुलेशंस को ईजी बनाता है. ओके, कॉम्प्लेक्स चीज़ों को ईजी बनाता है. मान ली कैसे, अगर मैंने आपसे पूछा कि 4 को किससे डिवाइड करना है, 7 से, तो नेगेटिव रिमाइंडर क्या होगा, कितना होगा नेगेटिव रिमाइंडर इफ यू डिवाइड 4 by 7. डेफिनेटली आई विल कंटिन्यू इन इंग्लिश. ओके, नॉट एन इश्यू. Negative remainders. If you divide 4 by 7, what will be the negative remainder? It will be -3, correct. Okay. So, negative remainders usually exist when our divisor, it is, I would say, greater. 7 is your divisor, 4 is your dividend, isn't it? So, suppose you divide 4 by 7, what will you do? If you are finding out positive remainder, in positive remainder what you do? 7 zeros are 0, you get 4. This 4 is what? Positive remainder. But if I tell you to find out the negative remainder, you divide 4 by 7, 7 1 just 7, 4 minus 7, you get -3. This is your negative remainder, isn't it? So, just take care of negative remainders. It helps us to ease our calculations, isn't it? Now, let me solve this question. I have 4 to the power 41 divided plus 7 to the power 41 plus 11 to the power 41 plus 17 to the power 41 plus 25 to the power 41, and this entire, okay, by 7, by 4, okay. This is being divided by 4. In remainders, we have a couple of theorems as well. What are those theorems? I am not using them here, I am just telling you, okay, because we will be using them in a while. Euler theorem is used in case of high powers, isn't it, when we have high powers. Then we have another remainder theorem called Chinese, or we in short call it CRT, Chinese remainder theorem. It is used when Euler fails. What we do in CRT? We break the divisor, right, break the divisor into product of two coprimes, product of two coprime numbers, right. This is when we have CRT. And finally, when we deal with factorials, we have Wilson remainder theorem. Here, if you solve this question, I know that my divisor can disturb the bases, isn't it? Powers here are 41, 41, 41, 41, 41, bases are 4, 7, 11, 17, 25. From the divisor, you can directly divide the base and replace it with remainder. So, from 4, if you divide 4 ki power 41, obviously, when this 4 divides this base 4, what do you get? The remainder 0, and 0 ki power 41 gives you 0 only. Here 7 divides, 4 divides 7. If 4 divides 7, what will be the negative remainder? Positive remainder will be 3, isn't it? If 7 is divided by 4, you get 3 as the remainder. But if you divide 7 by 4, negative remainder will be -1. So, -1 to the power 41. Can I write it? Then again, if 4 divides 11, if 4 divides 11, what is the negative remainder again? 4 3 are 12, that means -1 again. I just explained the concept of negative remainders, right? Then 4 divides 17, 4 4 are 16, we get +1 as the remainder. And finally, 4 divides 25, you get what? 1, and 1 to the power 41. This entire number will again be divided by 4. Yes or no? So, -1 to the power 41 is, I will just solve it here, -1, -1 to the power 41 is -1, and then there we have 1 to the power 41, that is 1, 1 divided by 4. Yes or no? Is it clear to everyone? Now finally, you just have to, these all get cancelled. we finally get a 0 divided by 4, that simply gives you 0, right? Hi, Ayushman, you can use that method as well, a ki power n plus b ki power n divided by a plus b when n is odd, right? Yes, only cat, you are saying that sir scratch se batana. I just explained from the very scratch. If you go back and check the negative remainder part, I have used negative remainder only over here, okay? I have not used these theorems. I just said that we in remainders generally have Euler remainder theorem, Chinese remainder theorem and Wilson theorem. Euler is used when there is high power. Chinese remainder theorem is used when we have high power but Euler fails, and we have Wilson remainder theorem when there is a factorial, right? Yes or no? When we have factorial remainder questions. So, even though we have high power here, but why did I not use Euler? Because without using Euler as well, if I simply disturb the bases, this is the sum that I have to divide by 4. 4 can disturb the base, I mean divisor can always disturb the bases directly and replace the bases with respective remainders. So 4 divides 4, remainder is 0, I got a 0, 0 ki power 41 is 0. 4 divides 7. See, in maths, we always have to ease our calculations. 4 divides 7, we can have two remainders, positive remainder 3 and negative remainder minus 1. So, I took minus 1. Why? Because minus 1 ki power 41 is a smaller number, minus 1, right? Then 11 is divided by 4. What do you get? Minus 1 ki power 41. Then 4 divides 17, we get remainder 1. 4 divides 25, we get remainder 1. So, 1 ki power 41, 1 ki power 41 that I have over here. So, 0, minus 1, plus 1, plus 1 all gets cancelled, 0 divided by 4, remainder is 0. This is an easy question, okay? You cannot expect such question in CAT unless they decide to give it, but I mean to just clear the concepts that divisor can directly disturb the bases, that is why we have used this. I hope this question is clear, right? And you should actually try to solve remainder question within 1 minute, okay? Such type of remainder questions under 1 minute. Now, try to solve this question, okay? I'll read it out for you. Find the remainder obtained when n is divided by 6 factorial, where n is 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial up till 89 factorial. So, 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial plus up till 89 factorial. This is being divided with 6 factorial, right? Try to solve it. Find out the answer. Now see, we can clearly see that 1 factorial when it is divided by 6 factorial, it's a small number, isn't it? 1 factorial is 1. If you divide 1 by 6 factorial, remainder will be 1, right? If you divide 2 factorial is 2. 2 divided by 6 factorial, remainder is 2. 3 factorial is what? 6. 6 divided by 6 factorial. 6 factorial is a big number, okay? It's 720. So 6 divided by 720, remainder is 6. 4 factorial is 24. 24 divided by 6 factorial is 720. Okay, 24 divided by 720, remainder is 24. 5 factorial is 120. Okay, 120 divided by 720, remainder is 120. So I can see that 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial will give me some remainder, isn't it? As soon as I come to 6 factorial, 6 factorial divides 6 factorial, what is the remainder? 0. 6 factorial divides 7 factorial. So over here, if I try to write down 7 factorial divided by 6 factorial, what will be the remainder? 7 factorial can be written as 7 into 6 factorial and divided by 6 factorial. It cancels, that means remainder given will be 0. So 6 factorial onwards, each and every factorial that I am going to get till 89 factorial, each factorial will have 6 factorial included. 7 factorial will have 6 factorial, 8 factorial will have 6 factorial, 9 factorial will have 6 factorial, you know, till 89 factorial. So obviously 6 factorial onwards, each factorial is going to give remainder 0 when divided by 6 factorial. Now 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, right? This is divided by 6 factorial is 720. So 144 and 9, 153. Yes or no? 153 divided by 720. 153 is my answer. So this is also an easy question, but I think a similar question has appeared in a lot of mocks earlier, है ना, और कैट में भी इस टाइप के क्वेश्चन आते हैं. वहाँ पे वी जस्ट गेट confused in some way कि how can I calculate this big sum, है ना. So there you have to be a bit smarter. Fine. I think this is also clear. It's an easy question, right? Yes or no? This is easy. Okay. Let's go to next question. Okay. Next question. 3 to the power, what will be the remainder when 3 to the power 114 plus 4 की power 96 plus 8 to the power 41 is divided by 7. So 3 की power 114 plus 4 to the power 96 plus 8 to the power 41 divided by 7. As I said, in remainders, you always have to come up with smaller numbers, smaller remainders. 7 divides 8. It is very clearly visible that 7 divides 8, remainder will be 1. So this 8 will be replaced with 1. 7 divides 3, remainder is 3 only. There is no such replacement. 7 divides 4, remainder is 4, no such replacement. But can I turn this 4 into something which on being divided by 7 gives me a smaller number? Now here you have to be smart again. You know that 4 cube is 64. 4 cube is 64. And 64 when divided by 7, 7 9 is 63, 1 remains. Can I just transform this 4 to the power 96 into 4 to the power 96 can be transformed to what? 4 cube to the power 32, isn't it? That means 64 to the power 32. Yes or no? So in the next step, can I do 3 की power 114 plus 64 to the power 32 plus 8 to the power 41 divided by 7. I have dealt with two numbers, okay. 64 on divided by 7 gives remainder 1, 8 on being divided by 7 gives remainder 1. I get 1 plus 1, that means 2. So now I am solving over here after this step, okay. I still have 3 to the power 114 here plus 1 divided by 7. Now this is something I have to deal with. Can I transform 3 into some other number? 3 can be made 3 square, it can be made 3 cube, it can be made 3 to the power 4, something like that, isn't it? If I turn this 3 to the power 114 into what? 27. So 3 to the power 114 can be written as 3 cube to the power 38, isn't it? And 3 cube is what? 27. 27 to the power 38. So 27 to the power 38 plus 2. 1 plus 1, 2 divided by 7. Now this 7 can directly disturb this 27, okay? And 7 when disturbs 27, 7 divides 27, I get negative remainder again, right? That is minus 1. So I get minus 1 to the power 38 plus 2 divided by 7. Minus 1 to the power 38 is 1, 1 plus 2 divided by 7. 1 plus 2 is 3, 3 divided by 7. That gives you 3, right? So all of you are experts at remainders already. Can we take 4 as minus 3, add 3 की power 114 and 3 की power 96 to get 3 की power 18? No. Hari Krishnan, so you have done a serious mistake over here. You are saying that 3 की power 114, 3 की power 114 plus minus 3 की power 96 should become what? 3 की power 18? No. Powers cannot be, you cannot do subtraction of powers like that, okay? Just recheck what you have done, okay? Write it down on a piece of paper, you will find your mistake. I want you to find your mistake, okay? I hope that is clear. Or other way to solve this question is, you have a big power here. Whenever we have a big power, then we should think of Euler. What does Euler do? Euler reduces the power, isn't it? But when do you apply Euler? You only apply Euler when the divisor and dividend are co-prime. So 3 and 7 are co-prime, yes. You know? This I have done without using any theorem, okay, because transformation was easy for me, right? Here, if you apply Euler theorem in this part, right? So Euler of 7 becomes 6, 6 divides power 114, we get a reduced remainder which is 2. So 9 divided by 7, that is, I mean, again you are coming up with that only, isn't it? Yes or no? Why only 27, why not 81? Because if you turn this into 81, okay, if you try to turn this into 81, so what will you do? You will do 3 की power 4 and then you again need to distribute the power, okay. 4 should divide 114. Does 4 divide 114? No. So you are stuck again. I mean, you will have to do something like this. This 3 की power 112 into 3 square and then you again divide by what? 7. But 7 when it divides 81, does it give me any small number? No. But when I transform this into 3 cube becomes 27, 27 on being divided by 7 gives me a small number. Try to generate small numbers in remainders, your task will be very easy. There are 1000 ways to solve one single remainder question. This question could have been solved with maybe transformation is one way, you could have directly applied Euler as well, isn't it? Nobody is stopping you. Use your own method. In remainders, the most beautiful thing is use any method. If you are mathematically doing the calculations correctly, then you will never get your answer wrong, okay. I hope this is clear. How does 3 by 7 become 3? 3 divided by 7, this is not a fraction, okay. Okay, in remainders class, whenever I will be doing this, that means I am dividing the number above by the number below, okay. So Ria, 3 by 7 is not a fraction, okay. What was I doing? I was dividing this by 7. So I am still dividing 3 by 7, getting remainder 3, okay. I hope this is clear. In fact, this should be clear because I have not used Euler. Even if you don't know Euler, तो भी आपको ये समझ में आना चाहिए because I have not used any theorem. I have used simple mathematics and the concept of negative remainders that I told in the very first, 2 minutes, right? Now you have another question which is 19 factorial divided by 23. Most of the people, they know Wilson theorem, okay. This is a question which will be solved by Wilson theorem. Why? Because here we have a question 19 factorial divided by 23. So a factorial divided by another number, this is a question of Wilson theorem. My first thought will be, does 19 factorial have 23? If 19 factorial has 23, I will straight away cancel it and get remainder 0, right? But 19 factorial does not have 23. That means it cannot be solved just like that. What is the other way around? Other way around is Wilson theorem, okay. Wilson theorem is a remainder theorem which works specifically in cases of factorial remainders. But for Wilson also we have some conditions. What are those conditions? Wilson has some proven I would say results already for factorial remainders. What are those results? First, if you have a number, okay, if you have any factorial number, okay, like this, p minus 2 factorial, I will write mod now, okay, mod p. Okay, let me tell you already that p is a prime number, okay. So when does Wilson theorem actually work? When suppose there is a prime number and it is dividing a factorial value which is 2 less than that prime. Let me give you an example, 11 factorial mod 13, isn't it? 11 factorial, 13 is a prime number, 13 is dividing a factorial value which is 2 less than 13. So this is one of the proven results of Euler theorem. Whenever you will see such a situation, the answer is always 1, okay. This is proven, fine. Second result is what? if you are dividing factorial of a prime number one less than the prime. So you are dividing the factorial of 1 less than the prime number. Prime number is p, you are dividing factorial value 1 less than that of the prime. In such case, remainder is always p minus 1. So if I transform this question to something like this, 12 factorial mod 13. 12 factorial divided by 13, remainder will be 13 minus 1, 12. Third proven result of Wilson is p minus 3 factorial divided by the prime, remainder is p minus 1 by 2, p minus 1 by 2. I hope this is clear. Is this clear to everyone? These are the proven results of Wilson theorem, isn't it? Yes or no? Okay, fine. Now let me work upon my question. Okay, one more thing. Wilson theorem does not have any proven such result for p minus 4 factorial divided by p. I mean Wilson theorem mein these are the three results that you can use further to solve your questions, but only these three are proven. Okay, so p minus 4 factorial divided by p, what will be the remainder? That is what I have over here. This is my situation, isn't it? This is a prime number, it is dividing a factorial value 4 less than that of the prime, right? ठीक है? So let me rewrite this. 19 factorial mod 23. 19 factorial mod 23. Do I really know the direct formula for this? No. But what do I know? That you have to make use of in Wilson. I know that according to Wilson, p minus 3 factorial mod p is p minus 1 by 2. So can I say that 20 factorial, I'll write over here, okay, we know that, this is something that we already know. We know that 20 factorial mod 23 will be what? P minus 3 factorial divided by p. What is the answer? P minus 1 by 2, isn't it? So p minus 1 by 2, 22 by 2, that means 11. So that means this is something that I know. If I take p minus 3 factorial mod p, that is equal to 1 according to 11 not 1, okay, according to Wilson, right? p minus 1 by 2. ये सबको clear है? Yes or no? ठीक है. I know this, but what do I actually want? I want to generate 19 factorial mod 23. Okay. You all know that this is my dividend, this is my divisor, this is my remainder, right? Yes or no? So can I say that, okay, just imagine 20 factorial is a huge number, isn't it? That is being divided by 23, the divisor, and remainder is this. So can I write, according to this equation, I hope you all know this equation, dividend is equal to divisor into quotient plus remainder, right? You all know this equation. What is the dividend here? What is the dividend? 20 factorial, right? So 20 factorial will be written as, can I write 20 factorial as dividend is equal to divisor. What is the divisor? 23. Do you know the quotient? No. इतना बड़ा number 20 factorial when divided by 23, quotient will be huge. So I don't know its value. Let me take the quotient as x plus, but I know the remainder, it is 11. So can I write down this right hand side as what? 23x plus 11? Yes or no? Can I write down this right hand side as 23x plus 11? I have explained. This is the dividend divisor. It's a huge number being divided by 23. Quotient will be huge. I don't know it. So dividend is equal to divisor 23 into quotient sum x plus remainder. Now what do you want? You want 19 factorial mod 23. This is what you need to generate. How can I write down 20 factorial? 20 factorial can be written as 20 into 19 factorial, right? Mod 23, and that should be equal to 23x plus 11, right? You have almost got what you needed. But when will you get this value? When this 20 goes below this number, isn't it? So this 20, 19 factorial mod 23. This 20 goes below this. Has everybody understood this till this point? Yes or no? Okay, good. Your entire answer lies here. How? You just need to solve this. How will you be able to come out with your answer? You just need to manage a number above which is divisible by 20. अब तो आपको समझ में आ गया होगा. This was my situation. I took the closest situation to it, which was p minus 3 factorial mod p, which can be written as remainder will be 11, right? In this case, I wrote down this as 23x plus 11, right? Now 20 factorial was broken as 20 into 19 factorial this. Now I need this. This will be equal to 23x plus 11 by 20. You just need to manage a number above which is divisible by 20. Yes or no? So if you put 1 over here, x equal to 1, what will you get? You will get 34 divided by 20. Is 34 divisible by 20? No. You put x equal to 2, you get 46 plus 11, 57 divided by 20. Is 57 divisible by 20? No. You put x equal to 3 over here, what do you get? You get 69 plus 11, 80. 80 divided by 20. Is 80 divisible by 20? Yes. So at x equal to 3, when I put x equal to 3 over here in this, I get 80 by 20. That gives me remainder 4, and that is my answer. So ऐसे questions, इसको बोलते हैं extension of Wilson theorem. Extension, I mean you knew this already, but you have an extension. Some way you have to extend this, right? So in such questions, suppose यहाँ पे 18 factorial होता है, your homework is solve with 18 factorial over here. Okay, try करके देखो, थोड़ा बड़ा आ सकता है number में भी, isn't it? So you will break it down again. You will start with this, and then you will take 20 into 19 over here, 18 factorial mod 23, and try to solve the rest of the things. Okay. I hope this is clear. How come 3? हाँ वो बड़ा आएगा साई भारद्वाज. Okay. How come 3? Because 3 is the only value at which this is. Okay. Okay. Tell me one thing. What is this over here? This is remainder. This is remainder, isn't it? 19 factorial mod 23 means I need remainder value. When this 19 factorial will be divided by 23, तो remainder will be an integer. Positive number ही होगा मेरा remainder, yes or no? So this remainder has to be equal to what? 23x plus 11 by 20. For this to become an integer, positive integer, I need to put such value of x. I will always start with 1, 0, 1, 2, 3 and so on, so on, so on. X equal to 0, this is not divisible by 20. X equal to 1, you get 34 divided by 20. 34 is not divisible by 20. X equal to 2, you get 57. 57 divided by 20, no, 57 is not divisible by 20. X equal to 3 pe, it becomes 69. 69 plus 11 is 80. 80 divided by 20, you get 4. That's your answer. That is when I am able to generate a positive integer, right? Sir, 20 factorial is dividend. Why did we write 20 factorial mod 23 as dividend? 23 तो मेरा divisor है ना, right? Yes or no? This is my divisor. This is my dividend. Okay? Just go back and listen to what I said again. Okay? We have few more questions to solve. Okay, 4 is the answer, right? You just need to watch this video once again and you will get it. Fine? इतना डिफिकल्ट नहीं है, जो मैंने कहा वो करो. इनफैक्ट यू कैन टेक सम क्वेश्चंस फॉर योरसेल्फ, चेंज द रिमाइंडर वैल्यूज. इसको आई विल जस्ट टेक अ होमवर्क प्रैक्टिस के लिए. 37 यहाँ करना, 37 इज अ प्राइम एंड यहाँ पे 4 रिड्यूस कर दो, कितना आएगा 33 फैक्टोरियल डिवाइडेड बाय 37. इसको आप अपने एंड से ट्राई करना. ओके तो वहाँ पे आपको एक रिजल्ट क्या मिलेगा ऑलरेडी, 34 फैक्टोरियल मॉड 37 इज इक्वल टू व्हाट, ऑलरेडी आप इससे निकालना 18 बचेगा एंड देन यू डू द मैथ. ओके दैट्स योर होमवर्क. Now we have another question to teach us a very good I would say technique as well, and something which can get you stuck in the exam. कैसे? Find the remainder when 20 factorial is divided by 289. There are two ways to do this question. Okay. What do you see? 20 factorial divided by 289. 289 क्या होता है? 289 is 17 square, isn't it? And 20 factorial is 20 into 19 into 18 into 17 into 17 into 16 factorial, something like this. Can I write it like this? 20 factorial 17 square. I can see that above I have 117, below I have a 17, I mean 2 17s. 117 cancels, 117 in the denominator. 117 has been cancelled, but you cannot cancel numbers like this. Whenever you are solving remainder questions, do not cancel like this. Okay? Why? Because if you are cancelling the something from the divisor, you are changing the divisor, which is not allowed. If you simply cancel 17 and forget it, you have changed the divisor. You cannot do that. So the 17 that you have cancelled, keep it over here. Very safe, because it is going to finally define my answer. Okay. What is going to happen here? I get 20, 19, 18, 17 is gone. I am left with 16 factorial divided by 17. Yes or no? The question looks very much doable now, because 17 will divide 20, remainder 3, 17 divides 19, remainder 2, 17 divides 18, remainder 1, and this becomes what? 16 factorial divided by 17. 17 is a prime number, 16 factorial is what? One prime, I mean prime value which is 1 less than 17, right? We'll use Wilson theorem. So if I ask you guys 16 factorial mod 17, what will be the answer? This is the perfect case of what? P minus 1 factorial mod P. In such case, remainder is P minus 1, isn't it? So P minus 1, that means 17 minus 1, which gives you 16. So this particular part is going to give me remainder what? 16. 17 divides 20, remainder 3, 17 divides 19, remainder 2, 17 divides 18, remainder 1, and 17 divides 16, remainder is 16, isn't it? And further 17 cancel thodi ho, right? Is not getting cancelled, right? Now what do you have? You have 16 divided by 17. Yes or no? 16 divided by 17 is minus 1. So this is minus 6 divided by 17. Yes or no? How? 17 divided 16, remainder is minus 1. 3 into 2 into minus 1 is minus 16 divided by 17. Now minus 16 divided by 17 is what? It is 11. कैसे? Minus 6 divided by 17. How is the remainder 11? You take minus common and deal with 6 divided by 17 inside. When you divide 6 by 17, you get negative remainder of what? Minus 11, isn't it? So minus is outside. I get minus 11 divided by 17, and that simply means minus minus I get plus 11. So 11 divided by 17, that gives me 11. Okay. 17 divides 6, you get minus 11. Minus 11 into minus is plus 11. So 11 is the remainder, isn't it? This entire problem, when I solved it, I am getting my final remainder as 11. But that is not the answer. That is not the answer. In fact, they will definitely plant 11 as one of the options. They should have done it. उन्होंने नहीं किया यहाँ पर. But दिस इज योर फाइनल रिमाइंडर. ये नंबर आप ऑलरेडी कैंसिल कर चुके थे 17. यू ऑलरेडी कैंसिल्ड 17 when we started, isn't it? You will have to multiply this 17 back with the remainder you have got, and that gives you 287 as your 187, right? 187 as your final answer. Yes or no? Which is option A. So this is also a very good question in which we broke down 20 factorial and 289, because देखो हमारे पास ऐसा कोई थ्योरम है नहीं, isn't it, कि 20 फैक्टोरियल को 289 से डिवाइड करो. तो what did we do? We broke it down, we cancelled 17, we kept it safely over here, then we went on with the rest of our problem. We got final remainder 11, and 11 will finally be multiplied with what was cancelled before, and that got me 11 into 17, that is 187. I hope this is clear. Rakesh Kumar. So Rakesh Kumar, you want a more theoretical and detailed video on this. I suggest you to just go to YouTube and search for Chinese and Euler remainder theorem. I have made a video. It's I would say it's a video in which I have clearly explained Euler, Chinese, Wilson, all remainder theorems. It's a detailed video. You should go and watch it. Okay. In that I have explained the concept as well. Fine. In fact, in this one as well, I explained Wilson theorem, isn't it, in the previous slide, and we just using the concept. I have not even used any concept over here, right? Yes, true in all cases. Your name is Sai Bhardeja, okay? So Sai, whenever you cancel any number during your calculation, you have to multiply it back, okay? But cancelled 7 was in denominator. 7 nahi, 17. Aniket, you need more practice. Okay, we'll come up with more sessions. Okay. कुछ नहीं किया हमने इसमें. We just transformed this, cancelled the 17, kept it safely, kept going on with our problem. We got remainder 11. But I told you, you cannot simply cancel the divisor, because if you simply cancel the divisor, then you are changing the divisor, which is not allowed. आपके क्वेश्चन में हमेशा always the divisor should remain 289, right? Okay, some of you are asking कि कैसे आपने, why did you multiply by 17? Okay, you have come till this point, isn't it? Let me use another pen. You have come till this point, minus 6 divided by 17, you got remainder 11 divided by 17. But was 17 your actual divisor? No, your actual divisor was 289. So you again have to finally make this 17 289. तो आपको क्या करना पड़ेगा? You have to multiply the numerator and denominator with 17, isn't it? अब दिख रहा है आपको 11 into 17 यानी 287 divided by 289. Original divisor 289. You are getting 11 into 17, 287 as the answer. Okay. Clear? Fine. So there are multiple ways to understand this. This was a multi-conceptual question. I mean, they have not straight away given you the question. You just have to break it down, transform it. Let's go to the next one, which is 33 to the power 199. 33 to the power 199 into 26 factorial divided by 29. This though you can do, isn't it? 29 divides 26 factorial. 29 is a prime. It is dividing a factorial value which is 3 less. P minus 3 factorial mod P. P minus 3 factorial mod P, according to Wilson theorem, is P minus 1 by 2. So what is your P? P is 29. Your prime is 29. This is only applicable for prime numbers, okay? So 29 minus 1 by 2, that is 28 by 2, that is 14. That means this part is going to give me what? 14. Let me keep the remainder 14 here, this part. Now 26 factorial will disappear, okay? 33 की power 199 divided by 29. Okay? I hope ये सबको clear है. Isn't it? Yes sir, but 20 factorial equal to 23x plus 11 by this, we replace this, I did not understand it. Khushi Agrawal, I'll go back, okay, once we reach the end of the session, do remind me, I'll go back and explain that, okay. Let's try to solve this question first. P minus 3 factorial divided by P, that gives you 14, so I replace this part with 14. Now 29 can directly divide 33, bases can be directly disturbed by the divisor. So 23 disturbs 33, 29 disturbs 33, remainder will be 4 to the power 199 into 14 divided by 29. Now just before applying any sort of theorem, try to see whether 4 can be transformed, this 4 की power 199 be transformed into something which on being divided by 29 gives you a smaller number. क्या आपको कुछ ऐसा मिल रहा है? 4 square 16, 16 divided by 29 does not give you any small number. 4 cube 64, 64 on being divided by 29, does it give you any smaller number? No, not like 1, 0, 2, nothing smaller, right? Now this is a case in which transformation is not that easily possible. In such cases, when you have huge powers, transformation is not possible. Go to Euler. Why Euler? I told you, Euler helps you what? In high powers. And why do we use Euler in high powers? Because Euler reduces the power. Right? Euler theorem reduces the power. But for Euler, divisor and dividend should be co-prime. So let me keep this 14 aside for a while, okay? Let me keep this 14 aside for a while. Let me just deal with 4 की power 199 divided by 29. 14 I have kept aside, okay? ठीक है. 4 की power 199 divided by 29. I am dealing with this. Huge power, 4 and 29. 4 and 29 are co-prime, isn't it? Yes, they have HCF 1. When are two numbers co-prime? When they have HCF 1. So 4 and 29 are co-prime. We have a huge power question as well. We can apply Euler. How to apply Euler? In applying Euler, first step is checking whether the divisor and dividend are co-prime. Yes, they are co-prime. If they are co-prime, next step is finding out Euler value of the divisor. So we have to find out Euler value of 29. How many of you know how to find out the Euler value of any number? Those who do not know, write no. Those who know, write yes. How many of you do not know how to find out the Euler value of a number? No. Sanya, you don't know. Pravar, you don't know. Diya, you don't know. I am happy to see so many no's here because at least you guys will now know कि Euler value कैसे निकालते हैं. Okay? If probably you would have attended iQuanta classes, they would have definitely taught you कि Euler, iQuanta की क्लास का I think मेरे को नहीं लगता कोई भी बच्चा ऐसा होगा who does not know how to find out the Euler value or who is hearing the term Euler for the first time. Okay? Okay. इसीलिए देखो लास्ट बैच शुरू हो रहा है, आप चाहो अगर इम्प्रूवमेंट चाहते हो, वो गैप्स जो आपकी प्रिपरेशन में आ गए उनको फिल करना चाहते हो, probably you can go for the last batch. Okay, we are going to teach this in very detail over there. ये तो एक प्रैक्टिस सेशन है, फिर भी मैं आपको बता रहा हूँ अच्छी खासी डिटेल में. Euler value, let's talk about Euler value. I'll just cancel this, okay? Let me cancel this. Let me teach you how to find out the Euler value. Okay? Euler value. Suppose I ask you Euler value हम किसी भी नंबर का निकाल सकते हैं, okay? We can find out Euler value of any number. Suppose I am finding out Euler value of 10. Euler value of 10. You are finding out Euler value of 10, that means first you do the prime factorization of 10. 10 is 2 into 5, okay? So Euler value of 10 will be 10 into 1 minus 1 upon first prime in the prime factorization. इसके prime factorization में पहला prime कौन सा है? 2. Close the bracket. 1 minus 1 upon second prime, which is 5. So 10 into 1 minus 1 by 2 is half. 1 minus 1 by 5 is 4 by 5. 2 into 5, 10 is cancelled. We get 4. 4 is the Euler value of 10. So if I write the formula of Euler value of any number n, it will be, write down the number first, then 1 minus 1 upon say a, where a is what? The first prime, okay? Into 1 minus 1 by b, which is second prime. and so on, 1 minus 1 by c, 1 minus 1 by d, whatever is the number of primes. Suppose I ask you another question. I'll erase this as well, okay, because we ultimately have to deal with this. I'll erase this. Suppose let us find out the Euler value of 100, okay, Euler value of 100. What to do first? Write down the prime factorization of 100. 100 can be written as 2 square into 5 square, right? There are two primes. There are two prime factors of 100, 2 and 5. So what will be the Euler value of 100? 100 into 1 minus 1 upon first prime, which is 2, into 1 minus 1 upon second prime, which is 5. That gives you 100 into 1 by 2 into 4 by 5. 2 into 5, this cancels. 10 into 4, 40. This is the Euler value of 100. Now, we are dealing with what? Euler value of 29. 29 के कितने prime factor होते हैं? Can anyone tell me how many prime factors does 29 have? How many prime factors does 29 have? Okay, Somi, you are saying 2. 0, Riya is saying 0. 29 का एक prime factor है 29. 29 has two factors, 1 and 29, because 29 is a prime number. 1 is neither prime nor composite. 1 को कभी भी prime में count मत करना, okay? 29 has only one prime factor. So 29 का Euler क्या होगा? The number itself, that means 29 into 1 minus 1 upon first prime factor, which is 29, into 1 minus 1 upon second prime. But do we have second prime number prime factor for 29? No. तो कितना आ जाएगा? 29 into 28 by 29. That cancels. You get 28. Or if I tell you a shortcut, let me write it over here. Euler of any prime number is always that prime number minus 1. ये याद कर लेना, okay? Just remember, Euler of any prime number is a shortcut. It is always prime minus 1. So suppose Euler of 7, it will be 6. Euler of 13, it will be 12. Euler of 29, it will be 28. What does this Euler value do? This Euler value reduces the power. What was the power I was dealing with? I was dealing with this huge power, 4 की power 199. 199 power है. इस 199 power को how is this Euler value going to reduce it? The Euler value divides the power and we replace the power with the respective remainder. So when 28 divides 196, कितना remainder आएगा? 28 divides 199. When 28 divides 199, remainder is 3. That means अब हम इस बड़ी पावर 199 को we will replace with the respective remainder, that means 3. Yes or no? तो यानी कि ये जो मेरा 4 की पावर 199 था, it has been reduced to 4 cube. 4 cube divided by 29, and 4 cube is 64. 64 divided by 29 is it's an easy game for us, right? तो अब मेरा क्वेश्चन क्या था? इस 14 को मैंने अलग रख दिया था, अब मैं इसको वापस लेकर के आऊँगा. My 29, because this was a Euler वाला situation, right? 29 finally reduced the power 199 to 3. The question has transformed into ओके हाँ, यूलर वैल्यू निकालते वक्त आपको कभी प्राइम फैक्टराइजेशन में अगर पावर्स दिखे तो पावर से कोई फर्क नहीं पड़ता. वी जस्ट नीड टू टेक केयर ऑफ हाउ मेनी प्राइम फैक्टर्स डज द नंबर हैव. सो नंबर इंटू 1 minus 1 upon फर्स्ट प्राइम, सेकेंड प्राइम, थर्ड प्राइम, वट एवर इज द नंबर ऑफ प्राइम फैक्टर्स. ओके, नाउ लेट मी फाइनली सॉल्व माई क्वेश्चन. दैट इज that will be what? This thing has been reduced to 4 cube. एक 14 मेरे पास अलग से था and divided by 29. 4 cube is 64. 64 divided by 29. रिमाइंडर कितना होता है? 8. Yes or no? 4 cube is 64. 64 divided by 29. Remainder is 58. 6, I guess 6, sorry. Right? 6. Yes or no? 84 divided by 29. 84 divided by 29. You have reached the end. Answer is 26. 29 to 58. कितना बचेगा? 26. That is the answer. Yes or no? 26 is your answer. तो आपका यूलर का भी मैंने रिवीजन करा दिया, मैंने आपको विल्सन भी बता दिया है. ओके, चाइनीज़ अभी देखते हैं अगर आएगा क्वेश्चन तो. ओके, क्लियर. सो टू फॉलो दिस, जिनको यूलर और चाइनीज़ नहीं आता है, अगेन आई एम सेइंग जस्ट सर्च iQuanta यूलर एंड चाइनीज़ रिमाइंडर थ्योरम ऑन यूट्यूब. एक वीडियो आएगा, उसका थंबनेल ही है यूलर एंड चाइनीज़ रिमाइंडर थ्योरम. क्लिक इट. 15 minutes video, you'll always be clear with Euler and Chinese. ठीक है. Now we come to questions where logic is involved. If the last two digits of 1 factorial, 2 factorial, 3 factorial, 4 factorial plus till 119 factorial is AB, we have to find out their last two digits. Then the value of A into B is. तो यानी कि आपको क्या डील करना है? यू टू डील विद द लास्ट टू डिजिट्स. बहुत ही अच्छा क्वेश्चन है. 1 फैक्टोरियल इज 1, 2 फैक्टोरियल इज 2, 3 फैक्टोरियल इज 6, 4 फैक्टोरियल इज 24. ओके, 5 फैक्टोरियल ऑनवर्ड्स एक चीज़ होगी. क्या होगी? 5 फैक्टोरियल में यू विल गेट 120, इजंट इट? व्हेन यू डू 5 फैक्टोरियल यू गेट 120. व्हेन यू डू 6 फैक्टोरियल यू गेट 720. है ना? तो 1 फैक्टोरियल, 2 फैक्टोरियल, 3 फैक्टोरियल, 4 फैक्टोरियल, 5 फैक्टोरियल में 120 आएगा, आप उसका 20 ही लोगे. अच्छा, एक लेट अस थिंक वन थिंग कि कहाँ तक करना पड़ेगा हमको ये सब लास्ट टू डिजिट्स. फ्रॉम 10 फैक्टोरियल ऑनवर्ड्स. इफ़ यू थिंक अबाउट 10 फैक्टोरियल, 10 फैक्टोरियल में क्या होता है? इफ़ यू टॉक अबाउट 10 फैक्टोरियल, 10 फैक्टोरियल में क्या होगा? यू स्टार्ट विथ 10, 10 9 8 7 6 5 4 5 आएगा एक बीच में, 5 4 3 2 1 ऐसे करके. So that means in the product 10 factorial, the entire product will have 1 0 from here and 1 0 is in 10. That means whatever is the product, 10 factorial onwards, 10 factorial onwards, each and every number till 119 factorial will have 2 or more zeros. Yes or no? 10 factorial onwards, all the numbers will have 2 or more zeros. When you have last two digits as zeros, do they contribute to the sum? अगर मैं आपसे पूछूं कि भाई 1000 है और 100 है और 25 है और 22 है, इनका सम करो. Suppose I'm just taking a situation example, okay? 1000, 100, 25, 22. If I ask you to add these numbers, 5 plus 2 7, 2 plus 2 4. Did these two zeros from 1000 or these two zeros from 100 have any impact on the sum of last two digits? No. That means whenever we have any such number which has last two digits as zeros, why I am talking about last two digits every time? Because last two digits is written. I am adding the last two digits of all these numbers. If I have last two digits as 0, they do not contribute to the sum. That means we will remove all such numbers from this series which have last two digits as zeros and they will start coming 10 onwards, 10 factorial onwards. तो यानी कि हमको कहाँ तक सिर्फ ध्यान देना है? वी ओनली हैव टू पे अटेंशन टिल 9 फैक्टोरियल, क्योंकि 9 फैक्टोरियल में क्या होगा? सिर्फ एक ही जीरो आ रहा होगा, राइट? लास्ट डिजिट आई एम सेइंग 0. सो 1 फैक्टोरियल, 2 फैक्टोरियल, 3 फैक्टोरियल, 4 फैक्टोरियल, 5 फैक्टोरियल इज 120. 120 की लास्ट टू डिजिट्स आर 20. 6 फैक्टोरियल की लास्ट टू डिजिट्स आर 720. वील टेक 20 लास्ट टू डिजिट्स. अगर मैं आपसे पूछूं कि 7 फैक्टोरियल में क्या होगा, तो 7 फैक्टोरियल में आप क्या करोगे? 720 इंटू 7 करोगे, isn't it? 7 factorial is 6 factorial into 7, 6 factorial into 7. So 720 into 7 में क्या होगा? 0 और 4, 40 आएगा, isn't it? Last two digits, so 40. राइट. तो वी हैव रीच टिल 5 फैक्टोरियल, 6 फैक्टोरियल, 7 फैक्टोरियल. अब मैं आपसे बोलता हूँ कि 7 फैक्टोरियल के बाद क्या आएगा? 8 फैक्टोरियल. इन 8 फैक्टोरियल व्हाट विल बी लास्ट टू डिजिट्स? तो 8 फैक्टोरियल क्या होता है? 8 फैक्टोरियल इज 8 इंटू 7 फैक्टोरियल. And when the entire thing, I mean the discussion is about last two digits, we only deal with last two digits. तो 7 फैक्टोरियल की भी last two digits ही देखो. वो आपको यहाँ मिली हुई है 40 इंटू 8 क्या मिलेगा? 320. 320 की last two digits क्या होंगी? 20. That means 8 फैक्टोरियल की last two digits क्या होंगी? 20. Yes or no? एंड 9 फैक्टोरियल की पूछूंगा तो क्या आएगा? 20 इंटू 9, क्योंकि ये 8 फैक्टोरियल है. 8 फैक्टोरियल में अगर आप 9 मल्टीप्लाई कर दोगे यू गेट 9 फैक्टोरियल. तो 9 फैक्टोरियल की लास्ट टू डिजिट्स क्या होंगी? 20 इंटू 9, दैट मीन्स 180. लास्ट टू डिजिट्स विल बी 80. बस 1 फैक्टोरियल, 2 फैक्टोरियल, 3 फैक्टोरियल, 4, 5, 6, 7, 8, 9. 9 फैक्टोरियल तक ही हमको जाना है. 10 फैक्टोरियल ऑनवर्ड सारे नंबर्स में लास्ट टू डिजिट्स विल बी 00. दे डू नॉट कॉन्ट्रीब्यूट टू द सम ऑफ लास्ट टू डिजिट्स, हेंस वी डोंट केयर अबाउट देम. 80, 20, 100. 100 की लास्ट टू डिजिट्स फिर से 00 हो गई. नॉट गोइंग टू कॉन्ट्रीब्यूट टू द सम, राइट. नेक्स्ट वी हैव 24 प्लस 6, 30. 33 तो इनसे आया फ्रॉम हियर. वी गेट 80 फ्रॉम हियर. व्हाट डू आई गेट? 113. 113 आ रहा होगा लास्ट टू डिजिट्स का सम. मतलब लास्ट टू डिजिट्स जो होंगी फाइनली एडअप करने पे दैट विल गिव मी 13 एज द लास्ट टू डिजिट्स, एंड दैट विल बी ए बी 13. वी नीड द वैल्यू ऑफ ए इंटू बी. क्या हो जाएगा? 1 इंटू 3, दैट गिव्स मी 3. दैट्स योर आंसर, 3. मोस्ट ऑफ यू आर एबल टू फाइंड आउट नाउ, राइट. सो दीज आर लॉजिकल क्वेश्चंस. ऐसे क्वेश्चन कैट में आते हैं. ओके वैसे आपकी बेसिकली कैलकुलेशन प्रैक्टिस, ब्रेन प्रैक्टिस के लिए है. ओके आई होप दिस इज क्लियर. ओके let's try to solve this question. We just have 2-3 more questions left and then we'll get going. Okay, remainder when 3 plus 3 square plus 3 cube and so on till a. इस क्वेश्चन को समझने में a lot of people face difficulty in understanding this question. Why? Because find the remainder when 3 plus 3 square plus 3 cube plus till 100 plus 100 square plus 100 cube. तो obviously 3 plus 3 square plus 3 cube. Next 4 plus 4 square plus 4 cube, then 5 plus 5 square plus 5 cube, 6 plus 6 square plus 6 cube, and so on till 100 plus 100 square plus 100 cube. So obviously after this there will be a term with 4 plus 4 square plus 4 cube, then 5 plus 5 square plus 5 cube, and so on till this point, right? So 3 plus 4 plus 5 till 100. So 3, 4, 5 until 100. This will be the sum of one of the brackets. Similarly, I'll have 3 square plus 4 square plus 5 square till 100 square. Right? Sum of all squares. And similarly, I'll have 3 cube plus 4 cube plus 5 cube till 100 cube. Isn't it? Right? What is this? Sum of first n natural numbers. Something like sum of first n natural numbers. This is like sum of squares of first 100 natural numbers. This is like sum of cubes of first 100 natural numbers. But in this, what is missing? 3 is missing. 3 is missing. I mean 1 plus 2 is missing, right? 1 plus 2 means 3 is missing. So from the sum of first n natural numbers, I just need to remove 3. So what is the sum of first n natural numbers? It is n into, sum of first n natural numbers is n into n plus 1 by 2. Sum of squares of first n natural numbers is n into n plus 1 into 2n plus 1 by 6. Sum of cube of first n natural numbers is n into n plus 1 by 2 square. Right? N into n plus 1 by 2. This will be the sum of 1 to 100. This will be the sum of 1 to 100. But I need to remove 1 plus 2 from this. That means 3 will be gone, right? This will be the sum. Okay. I'll finally divide it by 49 as well. Okay. Sum of squares of first 100 natural numbers, n into n plus 1 into 2n plus 1 divided by 6. From that I need to remove 1 square plus 2 square. 1 square plus 2 square is 5. So remove 5. Here sum of cubes of first 100 natural numbers, n into n plus 1 by 2 का square. तो n 100 into n plus 1 by 2 का square. लेकिन उसमें से क्या हटाना पड़ेगा? We don't have 1 cube plus 2 cube here. So 2 cube is 8, 1 cube is 1, that means 9 will be removed. And this entire thing will be divided by 49. Many of you might be feeling that this is very complex to solve. But 2 cancels 50, right? Can 6 cancel 201? देखो, 6 can be written as 3 into 2, right? 2 cancels 100, that means 50, and 3 cancels 201, that means 67, right? This 2 cancels 50. Okay? Yes or no? अब आप एक चीज़ देखो, 50 into 101 minus 3. Can I replace this with 50 into 101 minus 3? 50 into 101 minus 3. Okay? 50 into 101 minus 3. ये आ गया. Here 50 into 101 into 67 minus 5. 50, 101, 67. So let me just remove it. $50, 67 minus 5 यहाँ पे आएगा, and then we'll just erase rest of the part, right? This is what I get from here. Here I am getting 50 square, 101 square minus 9. So 50 square, 101 square, $50 square, 101 square minus 9, right? This is what I finally get, and this entire thing has to be divided with 49. Now the question is going to become easier. Why? Because if you divide this entire thing by 49, 49 divides 50 gives you remainder 1, 49 divides 101 gives you remainder 3, 49 divides 50 gives you remainder 1, 49 divides 101 gives you remainder 3, 49 divides 67 gives you remainder 18, 49 divides 50 into 50. तो 50 को डिवाइड करेगा 1, 50 को डिवाइड करेगा 1, 1 into 1, that means again remainder here will be 1. 101 को डिवाइड करेगा तो कितना आएगा? 101, that means 3, 3 का स्क्वायर. Isn't it? What do I finally get? I finally get, ये पूरा कट गया 0, because 3 minus 3 0. ये कितना आएगा? This is 54 minus 5, that means 18 into 3 into 1 54, 54 minus 5 49. तो ये आएगा पहला 0 plus 49, and यहाँ पे है 9, 9 minus 9 0 divided by 49. We finally get 49 divided by 49, that gives me remainder 0. 0 is the answer. I hope this is clear. Fine. So you're again using the same concepts, little more. I mean, I would say they have just tweaked the question. They just want to see whether you take the correct steps or not. If you take the correct steps, I think you will get the answer. I hope this is clear. We'll go to the next one. Okay. See, these sessions are going to be recorded anyway. Okay, you can always come back and check. This one, when 9876543210 is divided by 102. 9876543210 divided by 102. This is a problem in which you can either directly divide, but 102 से divide करना it's not easy, right? It's not easy. Then another way is you will try to use Chinese remainder theorem. What did I say? In Chinese remainder theorem, you break down the divisor into product of two coprimes. 102 can be written as 6 into 17. But is it going to work? What do you do in Chinese? In Chinese, there is a divisor above. You break the divisor as like this. I mean 102. 102 if you break into product of two coprimes, those are 16 and 17, isn't it? 6 and 17. We individually have to divide this by 6, find out the remainder. If we individually have to divide this by 17, find out the remainder. But if you divide this by 17, it is going to take a lot of time. You have to do the long division method, right? Just imagine you are dividing this by 17. There will be a big long division problem, right? What is the shorter way out? We see that here we have 102. Can I break this down like this? This is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digit number. Can it be written as 98 into 10 to the power, how many zeros do we have? 1, 2, 3, 4, 5, 6, 7, 8. Can it be written like this? 98 into 10 ki power 8 plus 76 into, after 76 we have 1, 2, 3, 4, 5, 6, we need 6 zeros, 10 ki power 6 plus 54 into 10 to the power 4, right? Then 32 into 10 square plus 10. This entire sum can be divided with 102. Yes, Ayushman, you are correct. Okay. Now 10 ki power 8 is something, it can be turned into 100, and once it is turned into 100, 102 will divide that 100 and give remainder minus 2. So 10 ki power 8 can be written as 100 to the power 4. Yes or no? 10 ki power 6 can be written as 100 to the power 3. 10 ki power 4 can be written as 100 to the power 2. And 10 square can be written as, I mean if you divide 10 square by 102, 100 by 102, you get remainder minus 2. So let me replace it with respective remainders. Okay. This becomes 4, 3, 2. Okay. 4, 3, 2. Now this 100 gets divided by 102. You get minus 2 ki power 4, isn't it? This 102 divides this 100, you get minus 2 ka cube, right? This 102 divides 100, we get minus 2 ka square, right? So finally, if I have to write this down, can I write it like this? 98 into minus 2 ki power 4 is 16. 98 into 16. 98 into 16. 76 into minus 8. Right? 54 into 4. 54 into 4 is 216. 216 ka plus. Minus 32 into minus 2, that means minus 64. Minus 64 plus 10. Okay. Minus 64 plus 10. Okay. Divided by 102. अब यहाँ से आपके लिए सॉल्व करना is quite easier, isn't it? 102 again divides 98 and gives remainder minus 4. Right? Minus 16 into minus 4. 16 into minus 4 is minus 64. Minus 64. Then minus 76 into 8. Minus 216. No, sorry, plus 216. And this was plus 64 over here, okay? Plus 64 minus 10, that means minus 54. Divided by again 102. I guess यहाँ से आप लोग solve कर सकते हो, right? Can you solve from this point onwards? Just find out your answer. Can you do it, yes or no? Can you all do it? I think it can be done, right? I have explained the approach, how to break it down, and why Chinese remainder theorem did not work, some other way did not work, and long division was a foolish idea here, right? Can you do it? We'll go to the next question and finish the session. First term should be minus 64. Yes, minus 64. I have written minus only, okay? Minus 64, okay? Okay, let's go ahead, okay? Solve this question, find out the answer. When a natural number p is divided by 18, remainder is 4. So, p is divided by 18. P is the dividend. Dividend is equal to divisor. Divided is 18 into some quotient. They have not given you the quotient. So, let it be x. Remainder is 4. Another statement is when a natural number q is divided by 9, remainder is 6. The remainder is r when p plus q is divided by 3. Okay. When a natural number q is divided by 9, remainder is 6. So, when it is divided by 9, quotient will change, right? जब हम किसी number को, when we divide a number by two different numbers, quotients are different, isn't it? So, that is the reason I have taken quotient y here and x here, different quotients. A remainder is 6. The question is asking the remainder is r when p plus q is divided by 3. So, let us do p plus q. If you do p plus q, that is 18x plus 9y, 18x plus 9y plus 10, isn't it? 18x plus 9y plus 10 divided by 3. That gives you what? 3 divides 18x. Yes, 18 is a multiple of 3, will always give remainder 0. 9 is divisible by 3, will always give remainder 0. So, 10 divided by 3, that gives you remainder 1. What is this 1? This is the value of r, because r is what? When p plus q is divided by 3, what we are getting is r. So, that simply means r is 1. The question asks, find the value of 16 minus 4 ki power r. 16 minus 4 ki power r is 1 divided by 3, 12 divided by 3, answer is 4. Yes or no? I hope this is clear. This is easy, okay? This is not even, I would say, cat level. This is very easy. Should we go to the next question? Okay, good. Next. A number is formed by writing the first 500 natural numbers next to each other as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up till 500. So, this is a series of first 500 natural numbers. Find the remainder when this number is divided by 64. Easy question, okay? Those who have studied number system in depth, easy question for them. What is your divisor? In remainder problems, divisibility questions, a lot can be answered through the number that we have been given. 64. It's a very special number. What is special about 64? 64 can be written as 2 ki power 6, right? You all know that divisibility of any number of form 2 ki power n. When you have 2 as the divisor, what do you check? When you want to check whether a number is divisible by 2 or not, what do you check? You check the last digit, isn't it? Suppose मैं आपसे पूछता हूँ कि if a number has to be divisible by 2, what do you check? The unit digit. If it is divisible by 2, number is divisible by 2. If I ask you the divisibility of 4, 4 is what? 2 square, isn't it? For 2, you check last digit. I mean, I would say 2 की power 1 का last digit होता है. 2 square, that means you check last 2 digits. When you have to check the divisibility of 8, 8 is what? 2 cube. You check what? Last 3 digits, right? Similarly, if I go to 64, which is 2 की power 6, what will you check? Last 6 digits. So, basically this question was planted to make you recall the divisibility rule of 2 की power n. If there is any number in the form 2 की power n, its divisibility rule is you have to check the last n digits. तो 2 की power 6 है तो last कितनी digits check करोगे उस number की? Last 6 digits. What are the last 6 digits of this number? This is a number which has been generated by writing down the first 500 natural numbers next to each other. So, last 6 digits will be 499500. That should be divisible by 64. You find out the remainder and that will be your answer. I hope you can do this, right? $499,500 divided by 64. यहाँ पे आप लॉन्ग डिवीजन यूज़ कर लो, जो यूज़ करना है करो. You can find out the answer. Yes or no? Last question for the day. Let's finish it quickly. Find the sum of all 3-digit even numbers that leave a remainder of 4 when divided by 5. If there is a number which leaves remainder of 4 when divided by 5, what kind of number that will be? Divisor is 5, quotient can be anything, remainder is 4. So that number will be of the form 5x plus 4. But what do they want? They want 3-digit even numbers. What is the first 3-digit even number that leaves remainder of 4 when divided by 5? First 3-digit number is 100. What is the first 3-digit even number which leaves a remainder of 4 when divided by 5? That is 104. Next even number of 3 digits which when divided by 5 leaves remainder of 4 is, क्या होगा अगला बताओ 104 के बाद? We'll just finish in 2-3 minutes, okay? 114, very good. 109, मैं चाहता था कि कोई कुछ लोग 109 आंसर करें. Couple of you have answered 109. Somebody has even answered. हाँ, 109 is wrong. It's odd. इसीलिए देखो आपको जबरदस्ती क्वेश्चन दिया. मुझे पता था क्वेश्चन में गलती करते हैं लोग, है ना? It's odd. You need even. तो 114 is that next number. 124 is the next number. This simply becomes an AP, and what is the largest 3-digit even number which leaves a remainder of 4 when divided by 5? It is 994. ये एक AP है. इसके टर्म्स का सम आपको निकालना है. यहाँ पे A है आपका 104, D is 10. It's an AP where first term and last term are given. You can use the formula n upon 2 A plus L. That is one way. Another way is you use n upon 2 2A plus n minus 1D. Right? I hope you can do it. n upon 2. Number of terms अगर आपको निकालने, कैसे निकालोगे? Last term minus first term. Last term minus first term divided by what? कितने का डिफरेंस है इनके बीच में? 10 प्लस 1 कितना आएगा? 890 by 10 18, 18 प्लस 1 90 टर्म्स हैं इस सीरीज के अंदर. ओके, सो सम कितना आ जाएगा? n अपॉन 2 a प्लस एल होता है. a इज फर्स्ट टर्म, l इज लास्ट टर्म. तो 90 by 2 फर्स्ट टर्म a इज 104, लास्ट टर्म इज 994. I hope you can find out this sum. $45 into 1098, Ayushman. 1098 into 45. Yes, you are correct. Okay, Ayushman. I hope the session was fruitful. कुछ चीज़ें आपको याद आई होंगी, जैसे यूलर तो अच्छे से ही मैंने करा दिया, ठीक है. यूलर भी करा दिया, विल्सन और अच्छे से करा दिया, राइट. एंड वी सॉल्व सम रैंडम क्वेश्चंस दैट कैन बी आस्क्ड अराउंड रिमाइंडर्स. आई थिंक यूलर के ऊपर और क्वेश्चन होने चाहिए. आई ट्राई टू ब्रिंग देम अप इन द नेक्स्ट सेशन. फॉर नाउ दैट्स इट. I hope you enjoyed the session. Put down your feedback, and if you need any improvement, let me know. And do solve numbers questions from PYQs, okay? Numbers के question PYQ से ज़रूर कर लेना, because that actually tells you कि भाई कि क्या क्या सोचना पड़ सकता है when you encounter a numbers का question. Okay? Please, one book which you can buy and study at home. You can buy iQuanta books, okay? सबसे updated material वही है अभी, ठीक है. देयर आर अ लॉट ऑफ बुक्स इन द मार्केट, बट अगर आपको सबसे अपडेटेड चाहिए तो आप वही ले सकते हो. इट हैज़ बीन डिज़ाइन कीपिंग इन माइंड द करेंट पैटर्न, डिफ़िकल्टी लेवल ऑफ कैट, ओके, दैट यू कैन टेक. एंड उससे अच्छा खासा पढ़ सकते हो आप. उसमें लेस क्लटर्ड है चीज़ें, ओके. देयर आर मैनी बुक्स बट दे आर क्लटर्ड. उनमें काफ़ी एक्स्ट्रा स्टफ लिखा हुआ है. इट्स, मान लो कोई और बुक मार्केट में मिल रही है इतनी मोटी, उसमें काम का पोर्शन इतना ही होगा, ओके. द एक्सरसाइजेज, थ्योरी एंड सोल्यूशंस, बाकी इज़ ऑल क्रैप, ओके. तो बेटर गो फॉर iQuanta बुक्स, ताकि आपका बुक्स का पाइल इतना बड़ा ना हो, उसमें आधा तो क्रैप ही होता है, इतना हो जाए, ठीक है. दे हैव इनफ क्वेश्चंस, गुड सोल्यूशंस, ओके, ऑल मेड बाय 99 percentilers, ओके. Thank you so much. I'll see you in few more days. I think I'll come up with another session soon. Thank you so much for attending. Bye bye.